Hey kiddos, if you've made it to this video, that means you've really been on task in class, and I greatly appreciate it. I cannot thank you enough. So our next learning target is matrix multiplication. Sorry for the shadows. I'm running out of daylight as I'm recording my last video for the day. Let's see, that's a little bit better. So we're doing matrix multiplication. So I'm gonna go ahead and give you a forewarning that this is not necessarily complicated, it's just very lengthy. I think colored pens will come in handy if you have those. I recommend using them. As always, pause the video if you need to get stuff written down. So matrix multiplication is when you're multiplying two matrices together. And it is not like matrix addition and subtraction where you just do it by element. That's not how matrix multiplication works. So we'll just go ahead and jump right into an example. So if you have matrix A, which is equal to 3, 3, 3, negative 1, and you have matrix B that is equal to 1, 1, negative 1, and negative 4. Okay, and we want to find AB. So we want to multiply matrix A by matrix B. So I'm going to show you an example of this all worked out on Delta Math in just a minute, but it is important to know that matrix multiplication is not commutative. It is not commutative, which means matrix A times B does not, put a hole in my paper, does not equal B times A. Okay, that is one of the most important matrix multiplication rules. Matrix multiplication is really heavily tested on the ACT. So make sure that you kind of master this skill. For the purposes of our unit, I'm going to teach you the long way. Once we finish the unit, I'll show you a little bit of an ACT trick for when you're doing matrix multiplication. Someone remind me if I forget to show you. Okay, so we want to find A times B. So when you're doing matrix multiplication, you always want to check the dimensions of your matrix. We're going to have a 2 by 2 matrix, and then we're going to have a 2 by 2 matrix. So that's good. The rule for multiplying matrices is that if the dimensions of your matrices, how do I explain this? Okay, so when you're making your boxes for your dimensions for each matrix, if the end number of matrix 1 and the beginning number of matrix 2 match up, that means you can do matrix multiplication, and your resulting matrix is going to be whatever numbers are left over back here. So in this case, we have a 2 by 2, so we're going to end up with a 2 by 2 matrix. So I'm going to go ahead and leave myself some room. You might not need this much room, but I just want to make sure that everyone can see and follow along. Wow, those are horrible brackets, but you get the point. So we're going to have spot 1, spot 2, spot 3, and spot 4. So if I want to find this first spot, this is in row 1, column 1. So that means for multiplication, in order to get this point, I'm going to take my first row in matrix A, and I'm going to multiply it by my first column in matrix B. So what that's going to look like is it's going to be 3 times 1 plus 3 times negative 1. Same thing for this one. This one is in row 2, column 1. So to get this spot, I'm going to do row 2 times my column 1. So that's going to give me 3 times 1 plus negative 1 times negative 1. Okay, so this is very much a step-by-step kind of process. This over here is going to be column 2. So this spot is in row 1, column 2. So matrix A, it's going to be row 1. Matrix B, it's going to be by column 2. That's going to give us 3 times 1 plus 3 times negative 4. And then lastly, this is in row 2, column 2. So row 2 in our first matrix times column 2 in our second matrix. So this is going to give us 3 times 1 plus negative 1 times negative 4. So I know that might have been confusing, so I recommend going back and re-watching that part. You're essentially finding what row it's in and what column it's in. The row is what you circle for your first matrix. So if this is A in our case, the column is what you circle in the second matrix. So B, row 1, column 1, row 1, column 1, row 2, column 1, row 2, column 1. Okay, so did I not read? Oh yeah, you just can't see it. The pink one is highlighted under there. You all saw me circle it. And then all you're going to do is simplify. So I was using purple. This is going to give me 3 times 1 gives me 3, plus 3 times negative 1 is negative 3. 3 plus negative 3 is going to give me 0 for my first term. Then we're going to have 3. 3 times negative 4 is negative 12. That's going to give me negative 9. 3 times plus negative 1 times negative 1 gives me positive 1. That's going to give me 4. And then 3 times 1 is going to give me 3 plus negative 1 times negative 4 is going to give me positive 4. So 3 plus 4 is going to give me 7. I'm sorry if you can hear that noise in the background. My heat just kicked on. So the resulting matrix for this one is 0, negative 9, 4, and 7. So I know that was probably a little confusing to grasp. So we're going to do another one. Please pause this if you need to keep getting it copied down. And I am going to move the paper from the screen. All right. So another example. We're going to have matrix A. Like this matrix A is going to be negative 3, negative 4, 0, and 3. And then we're going to have matrix B, which is going to be 1, negative 2, 1, and negative 1. So again, we have 2 by 2 matrices. That is what we're going to be working with majority of the time, so you really don't have to worry about what I mentioned earlier, but it is tested on the ACT, so try and get that in your noggin. So we're going to be resulting with a 2 by 2 matrix. So give myself a little less room than last time. Last time was a little obnoxious. Okay, so for the first one, we're going to have this element right here in green. This is going to be row 1, column 1. So row 1 in A. Again, we want to find A times B. Let me write that out to the side. We want to find AB. We're going to have row 1 times column 1. That's going to give us negative 3 times 1 plus negative 4 times 1. Okay. Down here, we're going to have row 2, column 1. So row 2, column 1. So we're going to have 0 times 1 plus 3 times 1. Let's see, what color have I used here? We're going to have column 2. This is row 1, column 2. So row 1, column 2. That's going to give me negative 3 times negative 2 plus negative 4 times negative 1. And then lastly, we are going to have row 2, column 2. So row 2, column 2. We are going to have 0 times negative 2 plus 3 times negative 1. And then we're just going to simplify. So this is going to give us negative 3 times 1 gives us negative 3, plus negative 4 times 1 is going to give us negative 4. That's going to give us negative 7 in that spot. We're going to have 0 times 1, which is 0, plus 3 times 1, which is 3. So 0 plus 3 is going to give me 3 down here. Negative 2 times negative 6 gives me, negative 2 times negative 3 gives me a positive 6, plus negative 4 times negative 1 gives me a positive 4. So we're going to have 10 up here. Then down here, 0 times negative 2 is 0, plus 3 times negative 1 is negative 3. 0 plus negative 3 is going to give me negative 3. And that is how I'm going to multiply those matrices. So I know that was a lot. Take it in. So before we work out another example, I am going to hop over to Delta Math and show you what I was talking about with the commutative property for matrices. So give me just a second to get that pulled up, because I am not very tech savvy. All right, here we go. So we want to do this. All right. So this problem, it tells us we want to, given the matrices A equals this and B equals this, we want to find the product of AB as well as the product of BA. So down here it has them labeled. Make sure you are paying attention to your labels. So the first problem is negative 3, negative 2, 3, negative 5, negative 6 times 4, 2, 6, negative 2. The second problem is 4, 2, 6, negative 2, negative 2, 3, negative 5, 6. So I know in our brains we're taught that like multiplication is commutative. So that means like 4 times 3 is 12, and then 3 times 4 is also 12. So that is commutative. But when we're dealing with matrices, so I'm just going to walk you through this example because I know that it'd be really hard for me to write this big on my piece of paper. I do encourage you to write this down on yours. Let me go ahead and zoom it in for you. So they went ahead and worked it out. So for A times B, we're going to have this this row times this column. I think I have pencil tools if I can figure out how to find them. Let's see. Okay, I don't know how to find the pencil tools, but remember, it's row times column, row times column. So I encourage you to pause this right here, get this copied down in your notes, highlight and circle the appropriate things. And A times B is going to give you 10 times 10, negative 10, negative 56, and 2. That is your first answer. And then if you, oh wait, there's my tools. Hang on. Oh, look at all these fun colors. All right. So for this one right here, remember it's your first row and your first column. For this one down here, it's going to be your second row and your first column. For this one over here, that's in our first row. This is in our second column. And then lastly, for right down here, that's in our second row and our second column. Well, look how fancy this is. Okay, so remember, row times column, row times column. That's why I recommend writing out your little spots first. That way you can know which row you're in and which column you're in. Makes it easy, a little bit easier to see. Oh, look at that, it stays up there. That's so fancy. But you're going to do the same thing here. We want to do B times A, not commutative. You're not going to get the same thing. So to get this one, it's this row times this column, and so on and so forth. I'm not going to draw them all again. But as you can see, this answer for a B, ooh, that's a horrible B. Hang on. This answer for a B is not the same as this answer for BA. So take some time, get that copy down in your notes, and try and get it through your brain that multiplication of matrices is not commutative. I recommend you pause here to get this written down. And if we look back on our assignments, I'm going to go ahead and say, actually, I'll save that till the end. Never mind. Okay, so go back, pause, make sure you get this into your notes, and then we're going to switch back to our note sheet and do one more example. Let's see. Let me find where I put our example. Dun, dun, dun. Okay, so our last example is I want you to try this one on your own. So I know I'm not there to actually know if you're trying this on your own. However, I encourage you to do so. So this is a 3x3 matrix is what we're dealing with here. We will call this matrix A, and we will call this one over here matrix B. And we want to find AB. So I know the examples that we did before were 2x2, but it's still the same process, row by column, row by column, row by column. So our resulting matrix is going to be a 3x3 matrix. I'm going to encourage you to pause it here. Okay, try and see if you can figure this one out on your own. And here in the next few seconds, I'm going to write down what the answer actually is. So please try it on your own. It will only benefit you as I write down the answer to put under the screen. Excuse me, sorry. Thanks to those of you that said bless you. So unless I copied this down wrong from Delta Math, this is the answer that you should get when you multiply that matrix. So in order to find this first term, you're going to do this row times this column, because this is in the first row, first column. Same thing down here. If you want to find the second term, it's going to be the second row times the first column. And lastly, if you want to find this term, that's in the third row in the first column. So the only difference between 2x2 and 3x3 is the fact that 3x3 is a little extra work because you're going to have an extra row and column of stuff in there, but it's no different for the skills. So if we go back to our Delta Math assignment, let's see. Okay. Oh, perfect. Okay, so we're going to see our Delta Math assignment here. So there's going to be 3 sections. So listen carefully. This is how I'll know if you actually watched the video or not. Remember, I can see that either way. I can't tell how many seconds of this video you watched, so please be watching it and taking notes. These first 2 right here are going to be required modules. So it's just going to be 5 by 5, just regular matrices, multiplying them. And then it's going to be 10 of doing A times B, working on that commutative understanding that commutative property doesn't exist for matrix multiplication, and also additional practice for matrix multiplication. This 3x3 matrix assignment is not going to be required. It's going to be extra credit if you do complete it. Okay, let me say that again. The 3x3 is not required, but it is extra credit. I don't give extra credit often, so I encourage you to take advantage of it, as well as I need to see work for this in your Delta Math notebook. I will be checking for it. This is matrix multiplication. It should take a lot of work. All right. Don't be doing anything sneaky and being like, oh, I typed it all on the calculator. That ain't gonna fly. Okay. You need to do this by hand for the purpose of this assignment. Capiche? Insert children saying kaposh. Okay. So that was a matrix multiplication. If you're watching this video, it means you're pretty far ahead of everybody else, and I greatly appreciate all of your hard work. Please make sure you are working the whole amount of class time. I'm hopeful that I'll be back in class tomorrow. But if you do somehow finish this assignment and the other assignment, please reach out to me and I can let you go ahead and move on to the next learning target. I don't have a video made for it as of yet. But if you're this far ahead, that means you're pretty good at catching on to things. So I'll let you go ahead and move on. So please be working for your sub. Please, I will be on I am available through Google Meet and email today, as I am working from home. So please, please, please reach out if you are struggling. Don't just sit there like a bump on a log, as I always say. But But I hope to see you all tomorrow. I miss your faces. Please get all the notes copied down. We'll try and regroup tomorrow because I'm sure we're all pretty much in different places. Miss you guys. Talk to you soon. Please reach out if you're struggling, and I hope that these videos were kind of helpful. See ya. Bye.